Hello, supply chainers, and welcome to our third live event of SC2x. First of all, sorry about the delay. Okay, so this is our third live event, and here with me is Ahmed Bilal. Hi, Ahmed.
Hey guys, how are you doing?
Okay, so the plan is the following. What we'd like to cover in this session is I'm going to be giving a brief overview of the exam. And let me share my screen to do that. Just 1 second. Okay, we are there. So what we would like to cover is the following. We're gonna start just giving a brief overview of the final exam, just final remarks that are important for you. Then the main focus of the live event is gonna be solving a couple of work problems. So I'm gonna be in charge of the first one about a transportation procurement problem, and then Bilal will help us to solve one problem related to discounted cash flows. And at the end, we'll open to any questions that you might have about the exam itself, or maybe about the content that we'll have in the exam. Without further ado, let's get started. Let's start talking about the final exam. So as you know, the final exam is an open book exam. So this means that you can use the KCD, so you can use the key concept document to solve the problems in the exam. You can also use the slides that we shared with you. You can also use your own notes. So any material that you have related to the course, you can use it. You can use it. The main goal of the exam is to assess your knowledge. So it's all about assessment and non-learning. So that's why we won't be providing any feedback or solutions during or after the test. Okay, so I'm going to be clear with this. So no feedback or solution will be provided at any time. So this is not new. We have this for the meeting, and this is a policy that is consistent across the different SCX courses. Okay, please keep that in mind. So regarding the timing, so the final exam will open next Wednesday. So that's tomorrow, July 3rd. As usually, will open at 1500 UTC, and it will close 1 week after. So we'll be closing on July 10, again at 1500 UTC. So the exam will be available for 1 week. However, please remember, please keep in mind that this is a time exam. So this means that once you start the exam, when you click on the start exam, you will have only 4 hours to complete the test. You can select the specific day when you want to take the exam. However, once you start, you have only 4 hours to complete the test. Okay, so let's talk about the content. So the exam will have 4 problems. So it will be covering basically all content weeks. So the first block of the course, which was from weeks 1 to 4, 1 to 3 and 4, and the second half of the course, which are the content of weeks 7, 8, 9, and 10. Okay, so basically all the graded content that was available for you is going to be part of this final exam. Please keep in mind that the final exam is worth a total of 45% of your final grade. So you are playing an important piece of your final grade in the final exam. So let's talk about some technical fields that are very important. So please remember that you cannot use the EDX mobile app to take time exams. So you have to use web browser. That's a constraint that we have. And additionally, we strongly recommend you to use your computer. So you can use your desktop or you can use the laptop, but please do use a computer to solve the exam. The exam is designed to be solved in Excel, so you can use Excel, but also you can use different optimization software that you are familiar with. So you can use SAS or Ample. Finally, the honor code. So remember that this is an individual exam, so the work must be on your own. So no collaboration in the final exam. So the staff, you can get in touch with us, but please just ask us about clarification questions. So no questions about the content itself, but maybe if you are not understanding the question, please send out an email to us at sc2x@mit.edu, and we'll be happy to help you. But keep in mind that this is just for clarification question. If something in the question is not clear for you, if you are not getting what the question is asking, please reach us to us. Additionally, please don't post any questions or any comments in our discussion forums or any other website. So we're going to be vigilant regarding this point, and we'll be keep some eyes in the discussion forum, but also we'll be searching in different websites. Okay. So with that, I will continue with the procurement. But before that, let me see if you have any questions. I'm going. Okay, no, we don't have any question. Well, the only question that we have is if the event will be available after this live event. Okay, so we will make it available. So we'll post all the content that we'll show today, and also we'll be putting the link of the video in week 11. Okay, so all the material will be available for you after we close this live event. Okay, so let's get started. So let's solve our first problem. So it's gonna be it's a problem that is related to transportation procurement. And let me talk to you about the problem. Let me read this paragraph. So we have this company, a Golden House, which is the largest distributor of wine in the U.S. And the company is currently opening a fulfillment center in Columbus. And the idea of this fulfillment center is to attend the new e-commerce channel of the company. And you have been tasked with securing the tracking services to handle all truck loads from this fulfillment center to 4 regional distribution centers that are located in Atlanta, Kansas City, Minneapolis, and New York. Okay, so basically the company is opening a new fulfillment center and is looking for tracking services to connect this fulfillment center to 4 regional distribution centers. So these are the lanes that we are looking for to hire for tracking services. All of the lanes are departing from Columbus. So Columbus is going to be the origin. And the final destination of these lanes are Atlanta, Kansas City, Minneapolis, and New York. So you are responsible for hiring these tracking services that are going to be serving these lanes. What information is available to solve this problem? So we were given with the distances, the distance that connect the origin and the different destinations, and these distances are expressed in miles. So for example, the lane that connects Columbus with Atlanta, the distance is 567 miles, and we have the same information for the other lanes. So you decided to run an auctions, and you received some bids from 3 main carriers, and these carriers are A, B, and C. And what they provide is just the bids, meaning what they will charge you if they get the lane. For example, carrier A will charge you $10.3 per mile. So this information is measured in dollars per mile. Okay, so what you need to do is you need to decide how you're going to be allocating the different lanes to Atlanta, Kansas City, Minneapolis, and New York to the different carriers. So basically the allocation of the loads that you have to send through these lanes. So we have for the first part of this problem, we have only 2 constraints. So the first one, of course, we need to satisfy a demand. So associated to each of the lanes, we have a demand, and this demand is measured in the number of loads that should be transported. For example, for the first lane, Columbus, Atlanta, there is a demand of 180 loads that should be fulfilled. Similarly, we have that information, demand information for all the lanes, and that's what we have in the column that is named demand. So that's the first constraint that we need to satisfy. The second one is related to capacity. So the carriers express their capacity in terms of the number of tracks that they can provide you. For example, carrier A it has a capacity of 150 tracks, carrier B of 250, and finally carrier C has a capacity of 900 different tracks. So this is something that we need to also keep in mind when we are allocating the tracks to the different carriers. So these are the only two constraints that we need to satisfy: demand and capacity. And of course, we would like to minimize costs. Okay, so then let's solve the problem. So let's start with question number 1. And the question number 1 is asking, how many track loads will you award to each carrier in order to minimize transportation costs? Okay, so basically it's asking for how many trucks or how many truck loads will award to the different carriers. And to solve this problem, let me go to Excel. And I think I have to stop sharing this. I'm gonna be sharing my screen. So let me see if you can see. Okay, we have it. Okay, I'm gonna make this bigger. Okay, I already put some of the information that is available for the problem, and I did some initial steps. So for example, what information is available? I was saying we have the distance to the different lanes. The first lane is Columbus, Atlanta, second Kansas City, and so on and so forth. So these are the distance, and these distances are measured in miles. Then we have the bits for the different carriers, the different lanes, and these bits are measured in dollars per mile. So the first thing that I did is just to convert these bits that are in dollars per mile to just dollars. And this is just simply multiplying the dollars per mile by the distance. So this is just a multiplication of 10.3 times 565. And I did the same for all the carriers and for the different lanes. So now we have the bits, we have the rates, and these rates are just measured in dollars. So this is what the carrier A, for example, will charge us if we transport one truck load from Columbus to Atlanta. So these are per truck load. Okay, so after that, what I have is a space, different cells that's going to serve as decision variables. So this here I'm going to be, or the optimization engine will be placing the number of truck load that will be assigned to the different carriers. Okay, so let's compute the total cost. So remember that we are trying to minimize this total cost, and this is just going to be the sum product of my rates that are dollar per track or per load and the number of loads. Okay, I'm using just the sum product function of Excel. Okay, so I already have my objective function. Then I need to add my constraint. Remember that for this question, we have only two constraints. First one, that we need to fulfill the demand. So we need to make sure that all the loads that are assigned to the carriers, so the sum of this row should be equal to the demand. Okay, so just I'm assuming all the loads that are gonna be assigned to each of the lanes. Okay, I'm gonna be doing something similar, but now with the capacity. Okay, I'm gonna be summing all the loads that are gonna be assigned to carrier A, and that value should be less or equal to the capacity or to the number of tracks that is available for carrier A. Okay, I'm gonna be repeating this, and we are all set. Okay. So we are trying to minimize costs. We have our decision variables, and we already have in place our constraints. So let me go now to solve it. Okay, I have it solved with me. I'm going to be just adding a few things. I'm going to be selecting cell C2 as the objecting function. Then I'm going to minimizing the objecting function. I'm going to be selecting the decision variables. Sorry, I'm a bit lost. My mouse is lost. My decision variables is all the cells that are colored yellow. Then I'm going to be adding my constraints. So only two constraints. The first one is that cells from F25 to F29 should be equal to the demand. Equal to cells from H25 to H2028. Okay, and finally, the capacity constraints. Similarly, so the sum, this sum, so cells from cells 29 to E29, so that should be less to the capacity. Okay, I'm trying to do that. Okay, I added that constraint, capacity constraint. I'm gonna be selecting simplex LP as a solving method and just solve it. Okay, so we find the solution. Okay, just to make sure that we are fulfilling all the constraints, so we take a look to the sum of the loads assigned to each of the loads. So we can see that we are fulfilling the demand. And also we can take a look to the capacity to make sure that we are not exceeding the number of trucks available in each of the lanes. Okay, so that's done. And the question was asking how many loads should assign to each of the carriers. So the answer to this question will be 150 loads assigned to carrier A, 200 to carrier B, and 310 to carrier C. Okay, so that will be the solution or the answer that you should be providing. Okay, so now let's move on and go to the next question. Question number 2. Okay, I'm gonna stop in sharing this Excel and let me share with you again my screen. Okay, so question 1 is done. So let's focus on question 2. And question 2 is asking the following. So to avoid handling split assignments, you want to make sure that each lane is awarded to only one carrier. In other words, only one carrier can be awarded all the volume of a lane. For example, all the volume shipped to Atlanta, 180 truckloads, must be assigned to only one carrier. And the question is saying, based on this new information, how many truckloads will you award to each carrier in order to minimize transportation costs? Okay, so this is different because in our solution, we were maybe using 2 or maybe 3 carriers for each of the lanes. But this question is saying that we can we have to award each lane to one single carrier. Okay, so let's try to do it that on Excel. Okay, I'm going to be sharing my Excel. Okay. So let's go now to problem 2. Again, I populated my spreadsheet with relevant information. So you will see that now, so besides having the number of loads that we will be assigned to the different carriers for the different lanes, we need to add additional decision variables, and those decision variables are going to be binary variables, because there is a constraint that is saying that the number of carriers assigned to each lane should be only one. So that's why in this part we are having these binary variables. Okay, so the cost is going to be exactly the same as before. So it's going to be just the sum product of the rates per load multiplied by the loads that will be assigned to the couriers. So that's exactly the same. We do have a demand constraint as before, and we also have a capacity constraints as before. So that's exactly the same as in question number 1. What we need to add now is the new constraint. So we need to make sure that the sum of these binary variables is equal to 1. Okay, that only out of these 3 cells, only one cell could take the value of 1. So in this sense, we'll be making sure that each lane is awarded by only is awarded to only one single carrier. Okay, so we added the binary variables, but now we also have to link somehow the flow variables that are the number of loads with the binary variables. So this is similar to what we observe in the network design problem when we add the linking constraint. So basically, I'm going to be taking the flow, the x, minus the y, which is going to be my binary variable, and that should be multiplied by a big number. And that big number for me is going to be just the sum of the demand. Okay, I'm going to fix in this value, and that will be all. Let me see. I'm going to be dragging the content, and same thing for the other cells. Gonna be just check for one of the values. So here I'm saying that multiplying the integer variable minus the binary variable multiplied by this big number. Okay, the sum of the demand. So we are all set. And remember that all of these values should be less or equal to 0. Okay, this is a linking constraint. Okay, so let's go to solver. Gonna be adding the objecting function. Again, the objecting function is cell C2, and we are trying to minimize the value of this cell. And gonna be choosing minimization. Okay, my decision variables now are different. The loads assigned to the lanes, but also the binary variables. So basically all the cells that are colored in yellow. Gonna be adding constraints. I'm gonna be adding with the constraints that we had before. First one is demand. So these cells should be equal to the demand that we observe for the different lanes. Okay, that's done. Then I'm going to be adding the capacity constraints, again selecting the columns, sorry, this row, and that should be less or equal to the capacity of the carriers, the number of trucks available. Okay, so that's similar to what we had in for question number 1, but now we need to add 3 additional constraints. The first one is that all my binary variables should be binary, actually, right? So I'm going to be selecting all of the cells, and I have to make sure that that's taking a binary value. Then I'm going to be making sure that this sum is exactly equal to 1. That's exactly equal to what we have in rows of cells age 34 to 37. And finally, we need to add the linking constraints. And the linking constraints is all of this, and that should be less or equal to 0. Okay, so my right hand side is going to be just 0. Okay, I think we have all the constraints. Going to be solving the problem. We have a solution. Okay, again, let's see if we are fulfilling the demand. Yes. Let's see if we're not exceeding the capacity. We are okay with the capacity. Our third constraint is now that each lane is awarded to one single carrier. Yes, we can see, for example, Atlanta is assigned to carrier C. Kansas City in a similar way. Minneapolis is assigned to carrier B. And finally, Columbus, New York is assigned to carrier 1. Okay, so this is what we want. So the problem was, the question was asking the number of carriers, sorry, the number of loads, and again, that's what we have in this cells. So 80 loads assigned to carrier A, 200 to carrier B, and finally 380 to carrier C. Okay, and with that, I will stop. So let's see if you have any questions. So before going or moving to the next question. Okay, so let me see if you have any questions. Okay. Okay, there's a question from Teyup. So he's saying, when do you set the demand equal to the amount, and when do you set the demand greater than the amount? So I think I would say that it's safer if you set as an equal constraint, especially when you are designing a network, when you are dealing with a network design problem. In those cases, when you set a demand constraint and using the greater or equal, and you have involved some level of service constraints. So this level of service constraint might make you to fulfill more demand that is needed. And that's reflected in sending, for example, in this example, sending more loads that are required, because the constraint is saying that you have to at least fulfill a specific value of the demand. Okay, so in this particular problem, I think you are safe, so you can use greater or equal. But as a general recommendation, I will encourage you to use the equal sign. Okay, another question. Okay, should we use an equal restriction with demand always? Okay, again, my recommendation is to use the equal sign. Will the exam be harder than this or similar to this one? So this particular problem was taken from large one of SC2x, so you can expect a similar level of difficulty for this upcoming exam as well. I'm going to be showing with you the solver box. I think that was not visible for you, but you will have, after we finish this live event, so you will have the Excel file, and you will have also the solver settings with it. Okay, so without that, let me hand it to Bilal.
Cool. Thank you, Sergio. Okay. So let's switch back to the presentation mode.
But that's I think how to switch to the PowerPoint.
Okay. Let's stay with this. Okay, can you help me with it? Okay.
Yeah.
Great. Okay. So this is a problem that now we'll be talking about. So I'll give you like a few seconds so that we can actually read through this question. Okay, so what is this question about? So this question is about Pet Feed, and they are a chain retailer that sells animal food. and they have to make a decision. And they're considering two options. Option one is that they can rent a store, and option two is actually they can actually purchase the store. So these are the two options that they have to decide. And then there's a lot of data that's actually provided in this question to help us figure out which is the best decision to make. Okay. So, and as you would have like guessed reading through this question, is that this is a question that's heading towards NPV. So what we need to do is to figure out the values of both these options, and then identify which option has the largest value. It's a very traditional and standard finance question, and a very important one indeed. Okay, so you see there are a lot of numbers there, and we'll talk about those numbers. But I mean, that's really the punchline, is that there are two options, and we need to make a decision on which option to go for. Okay. So we also have been provided with this table, and generally in the exam, we would provide you this sort of table. So you could always like copy this table and paste it in your Excel, and then take this as a starting point. Okay. So, and here you see the sort of questions that you can get in this exam. Now, like I said before, like this question is really asking you to determine the net present value of two options, buying and renting. But as you would see in the exam, we would also ask you like some intermediate questions, but they all lead to sort of the ultimate goal, which is to figure out the NPV. So why don't we actually figure out the NPV, and you would see like all the questions that have been listed here would automatically get answered. But in general, you see like three big questions here. We need to figure out the depreciation, we need to figure out the free cash flow, and then finally we need to figure out the net present value. Okay, so now I'm gonna open an Excel sheet.
Yeah, switch to Excel.
So I think
okay. So you need first to stop this one, then switch to Excel, and then share with them the Excel. Okay, you're ready to go.
Okay, awesome. Thank you, Sergio. Okay, so let me zoom in here. Okay. Wait, let me zoom out. Okay. So really, like I said, there are two options, buying, renting. So let's do it for the option of like buying the store, and then we'll do it for renting. The good thing is that the process is the same. You know, the numbers would change. So here you would see like sort of a template that I've already created. So we have the discount rate and tax rate mentioned here. This is really the table that has been given to you as a starting point. And then here I have sort of a framework I like to use for NPV calculation. And we'll talk about it once we reach to this point. But let's start by first like populating this table. So the first item that we need to enter is the revenue. And then this is the time period, year 1, 2, 3. So the revenue, as you can see, is basically 50 million. So in this table, everything is in million, and the revenue remain continuous throughout the next 3 years. Now let's talk about the operating expenses. Now, if we are buying the store, we also are responsible for maintaining the store, and so there's like a maintenance charge, and if you read through it, that is around 45 million, and that again remains the same throughout the years. And obviously, if we are buying, the rent is 0. We don't have to, I mean, it's our store, we don't have to pay any rent. Okay, So then we have the earning before interest, taxes, depreciation, also known as EBITDA. So in this case, this is very simple. You just take the revenue and subtract the expense. 50 minus 45, this comes out to be 5 million. And again, you can just scale it to all the years. So the next thing is depreciation, and this is really a tricky thing, but it's again very easy to calculate if you know how to go about it. So the question says, like, we're using straight line depreciation, and the formula for the straight line depreciation is basically you take the original value, which is the 80 million, you subtract the salvage value. The salvage value is the value of the asset at the end of its lifetime. So which here in this case is mentioned 20 million. Okay, and then you divide it by the total number of years this machine will be active, which is 3 in this case. This comes out to be 20. And again, this value remains the same in year 2 as well as in year 3. And in year 4, this goes down to 0. Okay, so then what we need to do is to calculate the earning before interest and taxes. This is really, we take this value and we subtract. Sorry. Give me a second. Oh, sorry. So I think I made some mistake here. Give me a second. Let me see if I'm using the right numbers here. Okay. Oh, sorry. So yeah, I put in the wrong value for the upgrade. This is supposed to be 10 million. But this was a good sanity check. So I was getting a earning before interest and taxes of minus 20 and something like that. So while this is possible, this could definitely happen, but this was definitely raised a red flag for me. And and when I reviewed that, you could see that the store upgrading expense was 10 million, but I had incorrectly actually used the value for the rent, which was 45 million. Okay, so now we have the EBIT here. The next thing that we have to do is to calculate the taxes. This is very important. The taxes is applied on the EBIT and not the EBITDA. So that's something you need to be really careful about. The tax rate is 0.1. The tax comes out to be 2 million per year. And we could then again just scale it across all the 3 years. Finally, we have the income after tax, which is really the EBIT, and we subtract the tax from here. So now I'm not able to select the cell.
It's good to know that some students are really following you, because we received, I believe, 5 people that commented that we're using the right value for renting for buying.
Okay. So So this is basically so we have reached to a point where we have the now net operating income after tax. Okay, the next thing that now we have to do is to figure out the NPV. So I like to use this framework. It's a very comprehensive framework, and let me just quickly go through the framework and then we'll fill in the numbers. So cash flow is basically equal to these 7 steps. The first is the investment, which in this case basically is the value of the asset, which is 80 million. So minus 80. Then this is after tax EBIT. So this thing is basically the same as net operating income after tax. So you could plug in the numbers, but you would get the same value as this. So I'm gonna just copy the value from the above cells. Then we need to add depreciation. Again, this is a very common mistake that people make. So depreciation is not a cash flow. It is an accounting procedure. And while it impacts the earning, as you saw here, but basically it needs to be added back because it's not a cash flow. So that's what we will be doing here. So we will now add back the depreciation while we are calculating the cash flow. Then we have the salvage value. So I'm not sure if we have used this same terminology in the course, but salvage value is really the market price of the asset after it has completed its lifetime period. So it has been again provided here in this question. If you see it is, I just want to make sure I use the right number here. So I think it's 20 million. Okay.
Yeah, 20 million after 3 years.
Yeah, so you add it after 3 years. Now 5 and 6 is something that you don't need to be concerned about, and we will not test you on these two things. But just for the sake of completing the framework, I have provided these 2 things. But text on book gain, just to a little bit tell you about it. So sometimes once you sell your asset at the end of, let's say in this case, 3 years, you might have to pay some taxes. So that taxes needs to be deducted. And similarly, if there is any opportunity cost, that also needs to be deducted from your cash flow calculation. Again, these are something that you don't have to worry about in this course and in the exams, but I've added it just for the sake of completeness. Net working capital, again, in this case has been specified. Nothing would happen. So again, this is something that you not need to be concerned of. So we're done with our numbers. Now what we need to do is to just add those things up, and we'll have the cash flow for all the years. So here you go. So we have the cash flow from year 0 to year 3. Now we need to sort of discount those cash flows. And so again, you guys probably already know the formula, but the way I like to do this thing is that you take the free cash flow, and then divide it by 1 plus the discount rate, which in this case is 0.09. Okay. And then raised to power the year that we're talking about, which is in this cell is 0. And then again, you could apply it to all the years. So if you look at again this formula, what we're taking this value, divided it by 1 plus 0.09 raised to power 3. Okay, so we have now the present values, and NPV is just about summing those values. So we just sum these values, and here we get our NPV. So again, a very good framework that you can use to calculate your NPV. Now you can do the same thing with renting. Really, nothing changes. It's the same. The only, I think the important thing is that, number one, when we are renting, there's no maintenance charges, but we do have to pay rent, obviously, which is 45 million in this case. And then the other important thing is that there's no depreciation. And that makes a lot of sense because you're not purchasing anything. There's no asset that comes on your book. So there's nothing to depreciate. So that remains 0 throughout. Rest everything remains the same. It's really just copying and pasting the above formulas into this sheet as well. And if you calculate the NPV, actually this should be PV and this should be NPV, it comes out to be 11.4 million. So really now we have the two numbers. If we buy, the value is 31.6. If we rent, it's 11.6. So what decision would you make? Obviously, we would go with the first option. There is an opportunity to create 20 million more value while going with the first option. So this is the end of the question. And if there's any, let us see if there are any questions on, if you guys have any questions on this
So
one.
before going to the question, so Bilal, have you used the NPV formula that it's built in Excel?
Yeah, absolutely. You can use that. I wanted to show it the formula so that you can understand what happens under the hood. But feel free to use that formula. It should give you the same answer.
Okay, so that will replace, instead of computing the PVs, the present values.
Yes, you don't need to calculate the present values. It will give you the net present value straight away.
Okay, awesome. So that's also alternative that you can use. So let's stop this, and I think I have a couple of questions for you, Bilal. Okay, so a question from Uni. So he or she saying, do you always subtract salvage value to get a depreciation?
Yes, you always do that. So sometimes you would say that the salvage value would be 0. In many cases, like the statement would be like, it will depreciate, and at the end of its lifetime, it would have no value. In that case, salvage value is 0. So you just take the original price and divide it by the number of years that machine or asset will be active. But the formula, like I said, for straight line depreciation is the price, the paying price minus your salvage value and divided by the number of years that asset or machine is active.
Okay, awesome. So we have just a final questions. So let's go back. So Tayyub is asking about, so going back to the first problem, the transportation procurement problem. So asking about what was the purpose of the linking constraints. So remember that you have to you use these linking constraints, as the name says, to link integer variables with decision variables, and that's very important in this problem, because if you are opening a lane, if the binary value for a lane is 1, you have to make sure that you are sending some or you are allocating some loads to the lane. Same thing with a neighbor design problem. Okay, so if you are not using, for example, a facility, if the flow that is coming out of the facility is 0, it's because that facility is closed. So that's the use of this linking constraints. Another question is saying that or is there any special function entered in the Excel in setting up the binary cells, or you only have to indicate the binary function in Solver? So there is no other function. So the only thing that you have to do is you have in Solver, you have to select all the binary variables and you have to set them up as a binary variables. So this is done in Solver, not in the spreadsheet itself. So final questions: how many numerical questions and multiple choice questions will be there? So we'll have 4 problems in the final exam, Bilal. 3 of them is gonna be mostly numerical, and 1 of them is gonna be more about quantitative. So it's gonna be a series of checkboxes. I think it's a similar format to what you had in the midterm exam. Okay, thank you, Bilal, for taking the time and for solving this problem. Any final comment to the students?
All the best for the final. You guys have done a great job throughout the course, and I wish you all the best. And I hope you'll do amazing in the final.
Okay, please keep in mind that the material that we show today is going to be available for you, the video and also the Excel files. And please take the exam as soon as you can. So don't wait until the last day, and do your best, and the best of luck in the exam. See you in the next opportunity.
See you.
Bye-bye.
Bye.